In this video, we're going to introduce you to vectors and some of their basic operations. So what is a vector? A vector is a directed line segment in the coordinate plane. So every vector has an initial point, its starting point, and a terminal point, its ending point. So typically a vector has an arrow on one end specifying the direction in which the vector is moving. So one way that we write vectors is in component form. So when we write a vector, it's kind of like an ordered pair with a comma in the middle, but instead of parentheses, we put these triangular brackets on the end. So I've drawn 3 vectors here, and we want to practice putting these vectors in component form. So to do that, we need to know the coordinates of where the vector starts, its initial point, and its terminal point. So for this first vector, its initial point P is at 1, 1, and its terminal point Q is at 3, 2. So to put that in component form, we subtract x2, which is 3, minus x1, which is 1, and then we subtract our y's, y2 minus y1, which is 2 minus 1. So 3 minus 1 is 2, 2 minus 1 is 1, so this vector is vector 2, 1. Okay, for this vector we have, I should have put a tick mark right there, we have point P, which is at 1, negative 1, that's our initial point, and we have point Q, which is at negative 1, 2. So for our component form, we always go terminal point minus initial point, x2, so that would be negative 1, minus initial point 1, and then do our y's, 2, minus negative 1. So you want to watch your double negatives there. All right, so for our x's, negative 1 minus 1 would give us negative 2, and 2 minus negative 1, double negative, so we're really adding, would give us 3. So this is the vector negative 2, 3. And then for this last vector, our initial point here, P, is at the origin, 0, 0, and point Q is at 3, negative 1. So when we go to find our component form, starting with point Q, since it's our terminal point, we'll do 3 minus 0, subtracting your x's, subtract your y's, negative 1 minus 0. That's supposed to be a minus sign, not a comma. So we get 3, negative 1. So this is the vector 3, negative 1. Okay, so what you'll notice is the component form of a vector basically just specifies the way the vector is moving. So this component form ended up being 2, 1. So if you take the initial point of your vector and try to move to your terminal point, you actually move in the direction over 2, up 1, over 2, and up 1. For the second vector, to get from P to Q, negative 2, 3, you have to move left 2 and up 3 units. So left 2, up 3. And then for the one that starts at the origin, right 3 and down 1, right 3 and down 1. So the component form is really just specifying the movement to get from the initial point to the terminal point. Okay, we can also perform vector operations, addition, subtraction, and scalar multiplication. So with addition, you're just going to add corresponding components. You're going to add x's to x's and y's to y's. So for addition, we're going to add negative 1 to positive 3, and we're going to get 2. So that's our new x component. And then for our y's, we're going to add 5 to negative 2, and we're going to get 3. That's our y component. That's our answer, 2, 3. The answer is sometimes called the resultant vector. So what you're doing here is you're adding corresponding components. Subtraction's the same way. You're going to subtract corresponding components. Now, there's a couple ways you can look at subtraction. Some people want to look at it as true subtraction. Negative 4 minus 2, and then write down your answer. And then -6 minus -1, and write down your answer. Other people like to go ahead and distribute the negative first, and then think of it as an addition problem. So however you do that, that's personal preference. You can think of it as, I want to go ahead and distribute and think of this as a -2, and then I want to add. Or some people think of it subtraction, just whatever works best for you. So I'm going to think of it as subtraction. I have -4 minus 2. That's going to give me -6. And then I have -6 minus -1. So that's really like -6 plus 1. That'll give me -5. So that's my answer for that one. -6, -5. Okay, scalar multiplication. Scalar basically means you're just dealing with one number out front, and you're going to distribute that number. So -3 times 4 is -12. And then -3 times -7 gives you 21. And there's your answer, -12, 21. So scalar multiplication is really distribution. You're just going to distribute that scalar that's in the front. Okay, so now we have 3 vectors given here, vector u, vector v, and vector w. Notice when you notate vectors, whenever you're letting a letter represent a vector like this, you always put a half ray on top, so kind of, or a half arrow on top. That's what lets you know you're dealing with a vector. So that's how you're going to notate these. So we have these 3 vectors, and we want to do these operations. So for number 1, we want to do 2 times vector u plus 3 times vector w. Try not to do too much mental math because you may miss a sign or something like that. So 2 times u, I'm going to go ahead and write out 2 times vector u plus 3 times vector w. And the order of operations somewhat applies to vectors. You're going to go ahead and multiply the scalars first before you add the vectors. So if we go ahead and distribute those scalars, we have 2 new vectors. 2 times -2 is going to give us -4. 2 times 3 is going to give us 6. And then 3 times 4 is 12. 3 times 6, 18. All right, 2 new vectors that we're now going to add. Now you add components. -4 plus 12 will give us 8. And then 6 plus 18 is going to give us 24. So your final answer is going to be the vector 8, 24. Okay, next problem, we have vector w minus 4 times vector v. Vector w minus 4 times vector v. All right, I'm going to go ahead and write down vector w, which is 4, 6. And then we've got minus 4 times vector v, which is 1, -5. Okay, so again, this is personal preference here. You can go ahead and distribute the positive 4 if you want to, and leave this as a minus sign. Or you can distribute the -4. If you distribute a -4, then this becomes a plus sign. So it's really however you want to do it, whatever makes more sense to you. I'm going to distribute a positive 4, and I'm going to leave this as a subtraction sign. Okay, so I'm going to go ahead and bring the 4, 6 over, and I'm going to bring the minus over. Because I'm bringing the minus over, I haven't used it yet, which means I'm only going to distribute the positive 4. So 4 times 1 is 4. 4 times -5 is -20. Okay, so now I'm going to apply the negative. Now I'm going to subtract. 4 minus 4 is 0. 6 minus -20 is like 6 plus 20, so 26. So the final answer is 0, 26. Okay, and then the last problem, we have 2v minus 3u. So 2 times vector v, which would be 1, -5, minus 3 times vector u, which is -2, 3. All right, go ahead and distribute the 2 and distribute the 3. Same thing here. You can distribute the positive 3 and leave this as a minus sign, or you can distribute the -3 and change that to a plus sign. Okay, so distribute that 2, which would give me 2 and negative 10. And I'm going to distribute a positive 3, which would give me negative 6 and 9. And now I'm going to subtract. 2 minus negative 6 is like 2 plus 6. That's going to give me 8. And then we've got negative 10 minus 9, negative 19. 8, negative 19 is your answer. So the main thing you want to watch on these operations is, number 1, follow the order of operations, and number 2, really watch your negative signs.